Welcome and thank you for following us. Safety lead time or safety stock. Is it a good idea? In short, no. It indicates that things are not under control in the business. It means the process is unstable, suppliers are not reliable or suffer from the same issues, so variability is unavoidable and thus a workaround is needed. Having that said, of course, we must assume that the business is working on a solution, and meanwhile, we need to firefight this problem to keep our production running. Most MRP systems have some built-in options to do so. First things first, both methods, safety stock and safety lead time, have about the same result. Basically, the business buys faster or more to cover periods of late delivery. From a personal point of view, safety lead time works with lower inventory, so for our video, we will choose that method. Let me explain first how we have set up this simulation so you can understand what is happening in this small business. On the left, we defined a source that just generates objects to work on. Next, we created a virtual processor that will act as our unreliable supplier. We added variation in the supplier's delivery behavior to simulate the fact that deliveries are not always in time. In our model, we assume that the supplier has 30 seconds lead time. That is not realistic, of course, but it is just to be able to explain this real time and not take too much of your time. So you can think in units, for example. So these seconds can be in fact hours or days. It does not affect the result, as you will see. For the delivery time, we added a triangular variation. So we expect deliveries in 30 days, or seconds in our model. Mostly, it will be 35 seconds. But this supplier seems to have his own interpretation of timings, meaning delivery can, rarely though, rise up to 80 seconds. So now we can collect the measurements. That is exactly what is to be done first, measure and analyze, because our definition or agreement was 30 days and reality shows differences. When delivery is done, our dear John is going to process the items. This process can be anything, so it's not named for. He needs 100 seconds or units to finish his job. Now parameters have been set by us in the model, but basically we do not know. So we assume the supplier will deliver in 30 seconds. So the best way seems to order on second 70, since the operator will be busy for another 30 seconds, and the supplier delivers in 30 seconds. Like this, we don't increase stocks, and the operator keeps working, like just in time. However, we see now that delivery time has variation, and basically our operator stops working due to shortages, so we will monitor his idle time. Now what has to be done is monitor the delivery times and make some statistics from it. We used the XMR chart. How to make this chart? We will explain at the end of this video. So to be 99% sure, we need to use the upper control limit. Within that range, this supplier will practically always deliver. This can be disappointing. Basically, you should invite our dear supplier for a good conversation or visit him to see how he manages his production. If not satisfied, then you know what to do. Good. Our model is set up to order just in time. On second 70, our operations line triggers the MRP to place a new order and delivery time starts. We know now that our operator is sometimes without work. By speeding up now, we see how our operator performs by measuring his idle time. For this, we use a state bar available in our simulation software. By speeding it up, we can see in the future without having to wait. Now we have a reasonable idea of the production loss that our dear operator is suffering from. It is clear our business is losing 15% of operator capacity. Now, in the following setup, we implemented the upper control limit that was about 72 seconds. So, the trigger to order will be set 72 seconds before our operator finishes his job. Remember, we had set it to 30 seconds because we assumed that delivery is 30 seconds from the MRP order trigger. As soon as our process reaches 28 seconds, that is 100 seconds of process time minus 72 seconds from our upper control limit the ERP system trigger an order to the supplier. So basically, when set in the MRP, this does not require a lot of attention from purchase. The consequence, as is the same for safety stock, is that our stock could rise a bit. That is the price we pay for having a supplier that is not consistent. So in all case, we need to deal with the supplier also. Great, so let's speed up and see what happens. The models show us now that our operator is not in idle anymore. And when we look at the in-between stock, this also looks good, meaning we do not see overstock growing. Now this heavily depends on the kind of business. So in our case, we are lucky that we do not grow overstock. This is mainly the reason why we prefer safety lead time over safety stock. But again, both method will work. Open a spreadsheet and type in the values in one column. Then take the average of the column. Next step is to calculate the relative delta between a delivery and a next delivery. Basically, that is the moving range. Drag down the formula. Next, take the average of the moving ranges. To calculate the upper control limit, take the average of the deliveries and the average of the moving range times 2.66. The constant 2.66 is a scaling factor used to convert MR into an estimate of sigma when moving ranges are based on a sample size of 2. Don't worry about this. It is part of a method that's been tested and proven to work well in quality control. Now, to make it easy, copy the column delivery in a new column. Use the delivery average as the X bar. Take the upper control limit value and put it beside the 2 columns and name it. Select the 3 columns and their values and make a quick line chart. Voila, you have a graphic representation where we are basically using the upper control as a limit for our model. That's it. We are done for this video. Want to learn more? Subscribe to our LinkedIn or YouTube channel. And don't forget, DataMath can help you to improve your skills or your production. Thank you for watching this video. We hope you can use it in your daily operations.